Solution guide for the review packet for quiz 2.8 and 2.9, which is all about percentages and some word problems involving percents. So the first set of problems is pretty standard. It's taking a percent and converting it to a decimal and also converting it to a fraction. So for number 1, the rule for converting a percentage to a decimal is simply to take wherever the decimal point is currently located and move it 2 places to the left. So in this case, the decimal becomes 0.17. Pretty standard percent to decimal problem. You can also make a decimal or a percentage into a fraction. The percentage would be whatever it is over 100. So this one would be 17 over 100. You should always try to reduce your fraction if you can, but in this case you won't be able to excuse me, because 17 over 100 doesn't reduce at all. So that one is a final answer as it is. Number 2 is very much the same. Again, as a decimal, move it 2 places to the left and it'll be 0.22. For the other part of this, to turn it into a fraction, it would be 22 over 100, and that one actually does reduce at least a little bit. 2 goes into both of those. It goes into the top one 11 times and into the bottom 50. So the final reduced fraction is 11 over 50. And number 3, basically the same idea. It's 68 and it's turned into 0.68 as a decimal. And as a fraction, if you started out as 68 over 100, you find the biggest numbers that go into that. Well, if you tried 2, it would still be 34 over 50, and if you tried 2 again, it would be 17 over 25. So it sounds like the biggest number that goes into it is actually 4 into both, which makes it 17 over 25. You can always use your calculator to reduce fractions. At this point, it's not such a big deal, as much as it is understanding how to write a percent as a fraction. But so saying 68% is the same thing as 0.68 or as 17 over 25. Alright, so now they maybe start to get a little tougher because the percents are not presented as a simple number like they were in numbers 1, 2, and 3. So again, if we follow the rule of 2.5%, we still move the decimal point to the left 2 places. So again, if it's 2.5%, we want to move it to the left 2 places, which is going to put it back here. We have to add a placeholder 0 in, so it's actually 0.025 as a decimal. And then as a fraction, we can start it with the same idea, 2.5 out of 100. But I don't want a fraction with a decimal in it like that. So what I'd like to do is see if I can figure out what 2.5 out of 100, if I turned it somehow back into a whole number. And a tactic I'm going to try is to divide it by, or excuse me, to multiply it by 2 on the top and the bottom, which is going to make this 5 out of 200. So that gets rid of the decimal part and makes it a nice whole number. But 5 over 200 actually reduces. If you divide them both by 5, 5 goes into the top 1 time and into the bottom 40 times. So 2.5% actually is the same as 1 out of 40. If we do 140%, again, same idea, right? Move the decimal point 2 places to the left. It's actually going to be 1.4, which is correct because we know that 100% is 1 as a decimal. So 140% should be more than 1. So then we also do the same thing with a fraction. It's 140 out of 100. Imagine if you had a 100-point test and you got 140%. It would be more than 100 points. And that's what that fraction indicates. Again, we can reduce it. Actually, this one reduces by 20. 20 goes into the top 7 times and into the bottom 5 times. And the last one, maybe the ugliest and toughest one, it's 0.5%. So if we wrote that, instead of writing it as a fraction, if we wrote it as a decimal equivalent, it would be 0.5%, like that. But we want to actually turn it into a decimal without the percent symbol. So again, I'm going to move it 2 places backwards, which is going to require me to put 2 placeholder zeros in there, like that. And then to make it a fraction, I'm going to have 0.5 out of 100. I'm going to try the same tactic as I did with number 4. I'm just going to multiply it by 2 on the top and bottom, and what's going to happen is 0.5 times 2 is 1, and the bottom 100 times 2 is 200. And our fraction is going to be 1 out of 200. The idea is maybe you can look at this and say, well, if I get 0.5 for every 100, then I have to get 1 for every 200. Right? In other words, I'll get 2 0.5s, or 1 for every 200. Okay, I'm going to slide this up a little bit. Let's take a look at the next step of this, which is given a decimal or a fraction, how do you convert that into a percent? Well, for a decimal, if you had a percent, you would move the decimal point 2 places to the left and you get the decimal. In the case of having a decimal, to get a percent, you move it back 2 places to the right. So this one is 28%. For fractions, it's almost as easy, except that in this case, you actually want to divide the two numbers. Literally type 13 divided by 50 on a calculator. If you do that, you're going to get 0.26, which you can then turn into a percent by moving the decimal 2 places to the right, and you'll get 26%. Another way to look at this one, just as an example, since it's out of 50, well, a percent fraction is always out of 100, so if I just made the bottom double, I'd have to double the top, and it would be 26 out of 100, which is also another way of writing 26%. So if we try number 9, the way I first suggested, if you divide, you're going to get 1.9, and if you move it 2 places to the right, it's going to be 190%. On the other hand, what if the 10, let's say it was 100, it would be times 10 to make that 100 on the bottom, and it would have to be times 10 on the top. And again, I know that 190 over 100, anything over 100 is a percent, 190. So there's 2 ways you can approach those. Either way is fine. Alright, for numbers 10 through 13, these begin the kind of problems where you're trying to convert something written in words, or at least kind of in words, into math so that you can solve it. So the basic rules are, anywhere you see a percent, you should change it to its decimal. Number 2, the word of means multiply. And number 3, is means equals. And the last thing that you would want is anytime you see the phrase what, like what percent or what number, here's what number again, that's going to be a variable. So if you look at number 10, 11, 12, and 13, they're actually easier because they're more simple expressions. When it says 3% of 100, what they really mean is 0.03 times 100. And if you just type that into your calculator, it's 3. The same thing goes for number 11, 100% of 3. Well, what's 100% of anything? That one we don't even have to work out. If we really wanted to, we convert it to a decimal, it would be 1.00 times 3. In other words, the answer is 3 again. But really, 100% of anything is just whatever it is. So 100% of 3 is just 3. 100% of a million is a million. How about here? 80% of 120. Again, all we do is convert it to a decimal. 0.80 times 120. You should get 96. For number 13, 150% of 6, excuse me, 115% of 6. Again, the decimal point is here, so we'll move it 2 places. It'll actually be 1.15 times 6. Since it's more than 100%, you should expect that the answer is going to be more than the original number. So 1.15 times 6. You can use a calculator to do that. It comes out to 6.9. Alright, once we start with number 14 through 17, they get to be a little bit more difficult because you need to be able to pay attention to how you actually solve the problem based on the wording of the problem. So for number 14, if you notice right away, it's going to be a little bit different. And I'm going to use some scratch paper now so I have more room. Number 14, if we write it from words into an equation, what percent of 128 is 32? That's the original problem. What percent is x? An unknown. Of means multiply. The 128 comes down. Is means equals, and the 32 comes down. So really what we have is x times 128 equals 32. And I think you all know by now that to undo times 128 so that the x will be by itself, we just divide by 128 and those will cancel. And we get x equals 32 divided by 128 on a calculator is going to give you 0.25. Now if you pay attention to what the problem actually asks you for, it said what percent, which means that I don't want this as an answer, I want to convert it back to a percent, which means in my final answer I'll move it to the two places to the right, and it's actually equal to 25%. So I wrote that out probably longer than most of you would write it out normally, but it's just to illustrate the idea of the thought process behind how you would do one of these. Number 15, same concept. Number 15 says 3 is what percent of 36? 3 is what percent of 36? So keeping with the pattern that we started with, 3 equals x times 36. And again, 36 is what I'm going to divide by. So when I take x, 3 divided by 36, I'm going to get 0.083 repeating. I'm just going to round to 0.083. And that's what x is equal to. But again, I'm looking for a percent, so I want to move this 2 places to the right. The answer to this is 8.3%. So I'm going to do number 16 now with the same pattern. Number 16 reads 23% is, or excuse me, 23.7 is 30% of what number? So number 16, 23.7 is 30% of what number? So again, writing it in the format that we've been doing, 23% equals, 23.7 equals 30%, but written as a decimal, 0.30, of means times, and what number means x. So as you can see, what I really need to do is get rid of the 0.30, so I'll divide it. And what happens is we get 79 equals x. Okay, if you look at our original problem, right, we were not asking for a percentage in this case. The percentage was given to us. So I wanted a normal number, so I don't need to move anything this time. That is the final answer. Let's also look at number 17. Number 17 says 7.5% of what number is 12? So it's actually written like a fraction. 7.5% of what number is 12. Okay, so I guess they're trying to make it as complex as possible by putting a fraction in here. But I think you guys know that 7.5% is the same thing as 7.5%. So really I'm not changing much here. I'm just showing you that this is the same exact problem. So we don't need that anymore. So if we start writing this like a math equation, 7.5% is going to be 0.075. Of means times. What number means x. Is means equal 12. And again, to get rid of the 0.075, I divide by 0.075 on both sides. And x, again, we'll have to do some calculator work. It's going to be 160. And once again, we were looking for a regular number, not a percent. So this is our final answer. Again, if you put it back into the problem, it should make sense. 7.5% of 160 is 12. So it makes a little sense if you read it like that. Okay, I'm going to move on and look at the last two word problems that we have. They're not too bad. I told you in class the number 18 is a lot like numbers 10 through 13, meaning it's a relatively straightforward problem. You just need to make sure you read it right. So it says, according to the U.S. Census, Virginia had about 7.1 million residents in the year 2000. Of those, 24.6 were under 18. To the nearest tenth of a million, how many Virginia residents were under age 18? So, okay, we're saying 24.6% of 7.1 million are under age 18. So all I really need to do is take 0.246, because I converted to a decimal, times 7.1 million. Now written out as a number, it looks like that. And I just use the calculator now. And it comes out to an answer of 1,746,600. That's how many people were under age 18 in the year 2000, apparently in the state of Virginia. So then we look at number 19. And 19 has a little bit of a different wording to it. First off, one of the things I noticed right away in number 19 is there is no percent written in the whole problem, which makes me think, since this is a percent lesson, that it's probably going to ask me for that. But it also says right here, what percent? So I know I'm looking for a percentage.
Jarvis Cruz is still in the building. Come to the front lobby. Your ride is here. Jarvis Cruz. Come to the front lobby. Your ride is here.
Sorry, apparently Jarvis needs a ride home. Okay, so back to number 19. It says a CD-ROM has 700 megabytes of storage space. What percent of that space is used by a file that takes up 154 megabytes? So you almost need to read this backwards. We're basically saying the 154 megabytes is what percent of the 700. So we're saying that 154 megabytes is what percent of 700 megabytes? Okay, well the megabytes things we don't really have to worry about. I just put them in there so you could see how we were reading it. But what we're really saying is 154 equals what percent, x, times 700. And so I'm going to divide everything by 700. And on my calculator, I'm going to say 154 divided by 700 equals 0.22 for x. And of course, as the problem stated, we want a percent, so we don't want 0.22, we want 22% as the final answer. Okay, so let's turn over to the other side of the paper then, where they're all word problems. And we'll start from the very top and work our way down. Okay, these ones, we had three kinds of problems. We had commission problems, interest problems, and estimating problems, where you find things like a tax or a tip or something like that. So commission problems work off the same principle. They work off the idea that commission is equal to the percent times the sales. So for number one, it says that he sells his home for $240,000 and he must pay the real estate agents a 5% commission. How much is the commission? So for number one, I don't know the commission because that's what they're asking me for. It's the last thing in the problem right there. How much is the commission? So the commission is what I don't know, but I know it's equal to the percent. Of course, we write it as a decimal, 0.05 times the sales, which were $240,000. And what I come out with is his commission equals $12,000. I'm going to let the screen catch up. It looks like it froze there for a moment. Okay, so let's look at number two. We still have a commission problem, but this one's a little bit different because they want you to figure out the total pay for a year, and what they tell you is that their pay is a base salary of $35,000. So the person's going to get paid the $35,000, but they're also going to get paid a commission, which is kind of like a bonus or an incentive on their pay. And what they want you to do is figure out how much that is. Well, if we see the idea is that the commission is 3% and her sales were $620,000, she's going to get the $35,000, but she's also going to get 0.03 times $620,000 in sales. So if we take 0.03 times 620,000 on our calculator, 620,000, it's going to come out to $18,600. So her total pay is the two of them added together, $53,600. So she gets a pretty nice bonus. Alright, and then finally, let's look at number three. Number three is the last of the commission problems, and it's just forcing you to look at which part of the problem are you not told and what part are you given. So again, if we're using the idea that commission equals a percent times the sales, or of the sales, right, times the sales, then our problem tells us that he earns 6.75% commission, so it's going to be 0.0675 where the percent goes. The question is, do I know the sales or do I know what he got as a commission? If I read through this, it says that he earns 6.75% commission, and then down here it tells me the publisher earns that. Okay, that was not the sales then, that's what he actually earned. So this is the commission. So I should write it here. And then when I don't know the sales, I can put as a variable. So I actually want to solve for the sales this time, so I'm going to divide by 0.0675 on both sides, and I'll get the sales. And it comes out to 1,250,000 in sales. Okay, on to number 4, which is now an interest problem. So the interest problems all work off of this equation, I equals PRT, where T must be in years. R is the interest rate. Use a decimal, not the actual percentage. P is the principal. Which is the starting amount. And I is the interest earned. So when you read through these problems, all you really need to know is which of the 3 variables are you given, and then which one are you trying to find. So for number 4, it says simple interest earned. Find the simple interest. I'm actually trying to find I. And it says 5 years, 1,200 invested, 2% interest. So P is 1,200. That's the starting amount. The interest, 2%, 0.02. And the time, 5 years. And in this case, all you have to do is multiply the numbers right across. 1,200 times 0.02 times 5. And you get $120. So this person made $120 in interest. Okay, let's look at number 5. 5 is kind of the same basic problem, except that there's a few little things that are different. So we're still using the same equation, same formula. But it says after 6 months, so okay, see 6 months is no good. 6 months needs to be converted into years. All you do is divide by 12. It's going to be 0.5 years. So we'll be using 0.5, not 6 months. $1.78 is the interest, and the investment is $8.90, so we need the interest rate. So we put the $1.78 here for interest. The principal was $8.90. The rate I don't know, that's what I'm trying to find, and the time is 0.5 years. So I can actually multiply 890 times 0.5 because it doesn't matter which of the multiplication I do first here. So I'm just going to do the numbers first. That's 445 times R. And again, I want the R by itself. So I would take the whole problem and divide it by 445. And those will cancel. And I come to find out that R is 0.004. And I want that to be a percent because I'm looking for the interest rate. So I'm actually going to move the decimal point 2 places back to the right, and I get a final answer for the interest rate of 0.4%. Which is pretty low, but unfortunately not all that uncommon. Alright, let's do number 6. Same kind of thing. One more time, an interest problem. Okay, number 6. I have $637.50 of interest. It says the principal loan is $2,500. The rate is 17, so I put it as 0.17 times the time, the only thing missing. So the way I solve this one, take the 2,500 times the 0.17. What happens is you get 637.50 equals 425 times t. And that makes it a little easier to solve for t. I just divide by 425 on both sides. And when I do that, I have to take 637.50 divided by 425. And I get t equals 1.5 years. Okay, we're down to actually my favorite problems on the paper, which are estimating problems. And I actually want to skip down to number 9 first, because I think number 9 is the best example of quick estimation when you might do it. So if we read through it, we're talking about somebody who has a wedding reception where the food and drinks total costs $1,492.50. But if you read through the whole problem, the whole thing says the sales tax is 7% and the restaurant adds 20% tip for large parties. Then A, B, and C ask you to estimate everything. So estimate doesn't exactly mean calculate. What they mean is get a rough idea. Well, I don't want to use $1,492.50 then as an estimate. What I'm going to say is that's about $1,500. Okay, here's what I would suggest you do. You want to learn how to figure out what 10% of an amount is and what 1% of an amount is. And it's a real simple thing, okay? 10% is found by just taking whatever you start with and moving the decimal point from where it is to the left one spot. So 10% would be $150. 1% is to do the same exact thing again. Move it to the left one place again. 1% is $15 in this case. So I'm actually going to work these in a little bit of a different order. I'm going to work out the tip first. So part B, the tip, 20%. Okay, well, how would I estimate what 20% is? Well, see right here, I just figured out what 10% is. So if 10% is 150, well, then I just multiply it by 2 so that I know what 20% is. So again, if 10% equals 150, then 20% is just taking it times 2, 300. Part A is maybe a little tougher because Part A wants to know what is a 7% tax. Okay, well again, I know what 1% is. So if 1% is 15, then 7% is just to think about, well, what's 7 times 15? Well, 7 times 10 is 70, and 7 times 5 is 35. That's 105. And so part C wanted the total. Okay, well, the total is $1,500 for the food and such, plus $300 for the tip, plus $105 for the tax. Grand total is about $1,905. Well, that's probably a little bit of a high estimate because remember we did it all based off of 1,500, so we rounded up, which means our estimates are rounded up a little bit. But that's a pretty good estimate to what these values are really. Another way of looking at it is if you went there with $1,905, you would at least have enough to cover the cost of this bill. Okay, let's take a look back then at number 7 and number 8. So number 7, I think we can write this one right underneath of it like this. What they spent? $16.98. Okay, but we're estimating. So $16.98, that's really $17. Okay. Using the tip rate of 15%. Well, here's what I do. I say 10%, move the decimal point one place, is $1.70. Well, how do I do 15%? 15%, well, that's like saying $1.70, but what's the other 5%? Well, how about this? If I took the 10% and divided it by 2, 5% is that divided by 2, that's 85 cents. So if 10% is $1.70 and 85 cents is 5%, then 15% is to add them together. Which if you add those together, you're going to get $2.55. Now is that 100% accurate? No, but it's awful close to correct. And the only difference is the 2 cents difference that we had between what our estimate was and what the actual price was. Alright, let's do number 8, last one. So number 8 is talking about the Wright Brothers plane model that costs $139.99. So what I see is $140. And they wants to know 4.5% of that. Okay, well, basically what I would say is, let's do this again from the principle of 10% is $14. Okay, well 4.5% is a little less than 5%. So what if I try to say, well, what is 5%? Well, 10% is 14. Half of that would be 5%, so 5% is $7. Okay, well, I don't really want 5%, I want 4.5%, but 5% is pretty close, so I know that 4.5% is just a little bit less than 5, so what could I say is a reasonable estimate? Take a little bit off. So maybe 4.5% is about $6.50, something like that. That's a pretty good estimate. If you actually went and calculated it out, if you took 139.99 times 0.045, you would get $6.30. So I think our way is a pretty good estimate to what the actual answer is. And of course, if you had to buy this plane and you knew you needed an extra, and you figured you had an extra $6.50 is what you needed for the tax, then you would actually be 20 cents ahead of what you needed, which is pretty good. So that's the whole purpose of estimating, is can I get a rough idea of how much money or whatever it is I might need to take care of my bill. Alright guys, that's it for the review packet then.